this is our blacksmith shop for our introduction to basic blacksmithing skills. And we have a number of forges here set up underneath the shelter that will allow us to have 5 different workstations that are called forges. And I'm standing by what's called a forge, and what I'm turning here on this handle is a fan that blows air into the bottom of the forge, or where the fire is going to be. The fire is going to be located here in the center of this cast iron table, and so we'll be burning solid fuel. Our other tools we use to hold the steel to keep from burning ourselves, and these look like pliers, but they're actually called tongs, and they're shaped on the end in order to handle the size and the shape of the metal that we're working with, so that we can comfortably hang on to the piece of metal and put it into the fire and remove it from the fire as it's hot, and then come to our anvil and do our hammering and shaping on the anvil. So those are primarily the tools that we will be introducing in the beginning. The one additional tool I'm looking for here is, I'm trying to pull it out of this holder, and it's got a sharp edge on it, and this looks like a chisel, and it is. In fact, it's called a hot cut, and it's called a hardy, H-A-R-D-Y. It's got a square holder on the end, and it fits into the top of the anvil, which has a square hole in it. And the square hole is called a hardy hole. So this is a hardy tool, fits into the hardy hole, and that holds that chisel, so we can then cut our metal with the sharp edge of that by laying the metal on top and then hammering the metal down against the sharp edge. Other tools fit into that same hole, and here is one also on the handle, on the holder there, and this is called a fork. And so it is used to help us bend our metal and shape it after we've got some of the basic hammering completed. So that's a fork. It's also a hardy tool. Fits into the square hole, has a square shank on there to fit the hole. So that's used comfortably in a hole like that. So that's what our tools that we'll be using in our basic class, and we'll be progressing here to show you the project that we'll work on utilizing those tools. This is going to be the beginning introduction to blacksmithing, starting from the very basic tools and materials and processes. And we're standing here in front of my regular forge that I use daily. And this is a forge using coal as a fuel, and the air is supplied to the bottom of the fire with a electric blower. And so you may hear in the background sounds of the blower going. I'll turn it on here. That's the sound of the air coming into the bottom of the fire. You can see the intensity of the fire as we add more air to it. So adding more air then increases the rate at which the coal is burning, and therefore the temperature of the fire in the coal goes up. A higher temperature then allows us to heat our material, which is in this case is steel. It's a low carbon steel, and mild steel, and relatively easy to shape in the process of forging. So we want to, that's the purpose of the fire. The fire is only to allow us to soften the steel to make it more malleable and forgeable. The tools that we're going to be using in addition to the forge then is our basic tools for blacksmith is the anvil and then a blacksmithing hammer. In this case it's a very heavy style hammer. It weighs almost 3 pounds and has a short handle. It's different than what you would find in your hardware store. It's called a cross peen hammer. It's got a shape on the back that goes across the handle. That's why they call it cross. And this is a peen. And the other side then is a flat surface with somewhat of a little bit of rounding on it to allow us to strike the metal and flatten it out and stretch it out. And I'll show you how we're going to use that in a bit. The other accompanying tool that we must have for this process is our anvil. So I'm going to use the anvil, and then I'm going to use associated tools with that anvil. And this is a hot cut chisel, has a sharp edge, and has a square tang on the bottom, and that is for holding it in the anvil. And it goes into a square hole in the top of the anvil. The square base fits into that hole snugly, and then therefore the tool is secured and can be used then without any safety problems with the tool falling or moving out. The top of the tool is sharp, and it's used for cutting the steel, but we only use this for cutting hot steel, so we'll heat the steel first in the fire and bring it over here and then do the cutting. This is not for cutting cold steel. We take that out for safety reasons as soon as we're finished cutting the material, and therefore we aren't likely to fall against it and have a safety problem. So in all cases, we are really concerned about safety, and some of the issues that, in addition to the sharpness of that, is that we want to wear a protection on our hands, and I advise and require actually to wear leather gloves, and I'll show you a pair. The ones I have are pretty grungy looking, but they work. And so they're workman's gloves, canvas back, leather palms, and so those are to protect our hands from grabbing or holding something that's hot. Everything in my shop I consider to be hot until I know that it's not, and therefore don't touch anything in my shop until you know for sure that it's not hot. The other thing that is important in the shop is to wear safety glasses for protection, and these are I require all my students to wear these, and they prevent any ash particles from the fire that may blow up in your eyes, dust or something off the surface of the anvil as you're striking the metal. There's what we call a scale, and it's just small dust particles like this of oxidized iron, and that could get in your eyes too. So we like to have glasses on, and if perchance you might strike something and a chip would break, could fly up into your eyes, and certainly that would be disastrous to have an injury in your eyes. So we always wear safety glasses. Other things, hearing protection sometimes is an issue, but almost not. With these anvils, and they're attached to a heavy wooden base, and so when they're struck with a hammer, there's not a lot of noise created, and so I found that hearing protection is really not a big issue in the shop. Even if there's multiple people working, the noise level is quite low, and not an issue. So from getting started from that, I think we'll show you what I find to be a very good way to learn some of the skills of blacksmithing. And this is going to be a project that can be taken home and used at home for anybody that does some cooking on their barbecue. So this is what I call a steak turner. And I have a display here of the project as far as the process step by step. And it'll allow you to follow through. I call this my storyboard on how to make the steak turner. The steak turner is made, in this case, from a piece of round steel. This is 5/16 inch diameter, mild steel, and it's about 20 inches long. And the first thing we do is we create a handle. We flatten out the end of the metal, and then so we can then shape the handle. So this is the shape of the handle here. I'll show you how to do that, and then we have something to hold on to while we heat the other end. And on the other end, then we go from a blunt cut off end, and we'll make a nice sharp tapered point on that end. And that tapered point, then we can create what looks like a hook, and that hook then is what will be used for lifting your steak or your pork chops off of the grill. And so this is the functional end, this is the handle end, and in between we have some material that it looks kind of boring, so we need to add some decoration to it. So we're going to put a cute little twist in the middle just for ornamentation and decoration. So that will allow us to have something that looks nice as it's hanging on the barbecue grill hook or hanger, wherever you're going to put it. So this project then introduces some of the basics of our blacksmithing skills and gets us started. We learn first to hammer out the material to make a flat surface, so that flat then can be converted into a handle with a little curl on the end. We'll bend that, we'll make this little hairpin curl on the top for the handle, and then we'll learn to convert the round material into a sharp pointy object on the end, and go through that process and how to bend the shape of the hook, and then come back and then how to create an ornamental piece in the middle by flattening the material and then doing the twist. All these projects and steps are done hot, and we do it step by step so that we can successfully end up with a piece that looks nice as well as being functional. The surface of this, as a final process, we will coat the entire surface of this with beeswax, melted beeswax on there, and then wipe it dry, and that will give it a nice black luster to the color of the piece, and protect it a little bit from corrosion and rust while we're using it, or get outside if it happens to get some moisture on it. It'll give us some protection. And of course the beeswax, even if it's on the end here where we're going to be picking up our food, the beeswax is edible, and so that's no problem. We're going to start with a demonstration on how to make our steak turner, and we'll start on this side, and we have the handle that we need to make the flat surface on, and the top of that handle is rounded so that down here on our finished piece we have a nice smooth end there. Well, the end of my steel bar is not rounded. It's squared off, so I need to do something on that end, so when I hammer this flat, that it will also be rounded. So what I want to do is to convert that squared off end to a domed end. So I'm going to do this first on my anvil with my Hardy hot cut. So I'm going to put this in the Hardy hole. My step and process is going to be to lay this piece of steel when it's hot on top of that hot cut, sharp edge, and I'm going to hit it with my hammer, and it's going to make a groove on the bottom, and I'm going to rotate my piece slightly in that groove and hit it again, and continue to do that, rotate it along the edge of that Hardy hot cut until I have a groove all the way around the piece of my metal. Then I'll come back and repeat that process. Eventually it will cut the end of that metal completely off. So I'll show you. I'm going to heat it up first. This is going into our fire. The fire here is the air from the blower has the temperature of the fire somewhere in the 2,500 to 3,000 degree Fahrenheit temperature range. And my objective is to get my metal up to a temperature somewhere around 1,500 to 2,000. Somewhere in that range is okay for what I'm going to do here for cutting. And how do I know it's that color, that temperature? I look at the color of the metal. So here's the color of the metal, and on the end of that piece, just bright, almost orange, and down here it's turning back to the black. So where my cross bar there is, when it's turning black, that's about 1,000 degrees Fahrenheit. Up at the top, when we came out of the fire, that was probably close to maybe 16 or 1,800 degrees Fahrenheit. It's now down to like a dull red, and if you can see that color, it's somewhere around 1,200 degrees. So I need to go back into the fire now, reheat it back up to do my cutting. While we're waiting for that, I'll just introduce some of my tools that I use for my fire management. This is what I call a rake, and so it allows me to drag some of my pieces of coal that are burning in the fire back into the center of the fire. And this is a poker. It's got a little hook on the end, and I can go down into the fire and loosen up some of the chunks of fuel that's down in there and play around with it. So these are my fire playing tools. So that's one thing in common that most blacksmiths have, is they like to play in the fire. So this is I'm coming out of the fire at somewhere around that 1,800 degree range, coming over to my sharp edge here and making a groove on the bottom, turning my metal, following that groove so it will be all the way around the metal, and I will then have a sharp cut in around the circumference of that piece of metal. I can come back in, repeat that while it's still hot. I'm still somewhere around 11 or 1,200 degrees, so I can continue to do this cutting on the sharp edge until I get down to the temperature like now. At the bottom of that is too cold to cut, and it will break off. So I want to actually cut it and not break it. I'm going to go back into the fire, reheat this, turn my air on a little bit faster to make the fire run hotter, but I'm only needing to heat the end of my bar. The center of the bar back is not necessary to heat. I'm only heating the part that I'm working on. So in all cases in our project, it will be important to heat the area that we're going to do our hammering and our forging. So I'm going to cut this off now so it'll be completely separated from the bar. And so I have now a sharp pointed domed shape, and that little sharp end on there, I would really like to get rid of that. So I'm going to hammer that by just dropping into the surface of the anvil, and that will knock that little sharp point back in and smooth it out so I don't have a burr on the end of the piece that I'm going to hammer. I've removed my hardy hot cut because that's, again, dangerous to have it in there, and I might trip and fall against it. So I take it out, put it back in its holder. In this case, now I'm going back into the fire, and I'm going to work on making the end of the piece here flat, and I need it to be flattened as large as what my hand will be to hold the handle, and allow for a little bit of a curl on the end, and also allow for a bend on the top. So I will go to the anvil, and I will use the anvil and the hammer to flatten this out in preparation for making the shape, the bending shape. So we kind of came out of the fire a little bit hot. We saw some sparks coming out of the fire. Those sparks were really burning the outside surface of the steel, so it's really hotter than what I intended it to be. And it's kind of destroyed some of the outside surface steel characteristics, but not bad enough to cause any damage here. I'm going to hammer this material down with my blacksmith hammer, and make the end of that where I cut it off will be rounded. And now I need to make that flat area longer to make it long enough for the handle. So I will continue to hammer ringing to me a little bit. I'm going to try to tighten that anvil down against the stump and reduce some of the ring. These nails are railroad spike nails that are holding the anvil to the stump, and sometimes after I'm using it repeatedly, it tends to loosen some of those nails, so that's why it was vibrating. I need to bring this metal back up to working temperature, and we'll watch the color of the metal in the fire, and when it gets up to the temperature, if I can again repeat the hammering process, I will do that. You'll notice that while I'm hammering, I have the metal on the surface of the anvil, and my hammer is hitting directly into the flat surface of the anvil. I'm not hitting out here off the edge or anywhere else. I'm hitting exactly in the middle of my material against the flat surface of the anvil. So if I want to make my flat longer, I move my metal under my hammer. So rather than move my hammer, I move my metal. My hammer continues to hit in the same location on the anvil. So I'm extending my metal further and further underneath my hammer, and then I will bring my metal back in order to blend in. When my hammer blows, it left some marks, and I will bring my metal back under the hammer. So I've flattened it partially. I need a little more length in my flattened area to make the handle long enough for my hand, and I need to be a little bit thinner and spread it out to be a little bit wider. But basically the process will be the same. I'll go back into the fire, repeat the heating, and come back and repeat my hammering on the anvil. So every time we go into the fire, we call that a heat. So the process, this is a second or third heat for this particular project. So each time I return back to the fire, in blacksmith terminology, that's another heat. It's a heating process. So it's another heat. So you can see my shape of my flattening has now taken on some little bit of curvy characteristics. The reason for that is I have not successfully hammered the piece of metal in the same spot all the time. Sometimes I hit too much to one side, or some too much to the other side. If it bends to that side, I probably hit more on that side and cause the metal to stretch and make a bend like this. So to straighten it out, I'd have to hit on the inside of the curve, and that will straighten out the metal. It'll just make the metal on that side longer and counter the bending and curving effect. I can also turn it on its edge, this being the edge, turn it like this, and I can strike with it down, and it will create a little bit of straightening effect. And so I can manipulate the straightness however I want by those two processes. The other thing you can do is say that's very artistic and just leave it the way it is, and go ahead and make your handle. If I was being very concerned about the shape and the lines of the edges of this, then I would have to flatten it and straighten it and work with it. If I'm looking more from the artistic side, I can get by with leaving it as is. I'm going to do a little bit of both. I'm just going to straighten it out slightly on the edge, and just so when I bend the handle, it comes back in good shape. So I need to have a handle that's about 6 inches long. So I have a measuring stick here. There's no numbers on it, but I know that the width of my anvil from one side to the other is 4 inches. And so I can look at it, and I lay my piece down, and I have 4 inches plus a little bit more. So I need to add maybe 2 more inches in order to get about 6 inches. So I use my anvil as my measuring gauge. And I do this often. If I don't really care what the numbers are, I just know how much length I need. I'll use my various locations on my anvil in order to give me a measuring stick for that process. We'll come back and add some more length to that flagging. That's about my 4 inches plus about 2 more inches. I think that'll do my handle very well. My next step then, look at my storyboard. Where are we going to go? Next step is we need to make a little curl here. This is a little convenience stop for your finger to rest against. And then after we do that, we'll progress up and we'll make this bend up here at the top. So this is our next move on our project, is to make this curl. So we're going to make that curl by using some of the shapes of the anvil. And the anvil has, on this end, has a rounded shape. It's a tapered cone. We call it a horn. And so it's going to taper all the way from a large 4-inch diameter down here to a very sharp point. So I'm going to look at the shape of this. I'm going to look at my finger and say, I need something that my finger will rest against. And so I need a size about the size of my finger. So I'll lay my finger on here and sort of look at where my finger diameter is the same as my anvil, and then I can pick the area on the anvil that will allow me to shape the end of this the size of my finger, the shape of that into the surface of the anvil until I have a little bit of a bend, just enough to hold my finger from slipping off that handle. So that's all I need to do, and I accomplish that by hitting the metal, the hot metal, against the surface of the anvil horn at the diameter where I was working. So now we need to make the handle in a hairpin shape. So I need to make this little hairpin bend right here. So we're going to use another tool that I introduced here on the anvil, and that is a fork. We call it a bending fork. So it's got 2 prongs. It's got the hardy base, so it fits very conveniently into our hardy hole. And that allows us to hold this piece of metal and then shape it around one of the sides of the fork. I need to get my metal hot. I'm going to be bending and bending here where I stopped hammering. It's about the location I'm going to be focusing on, and I'm going to bend it around one of those sides of the fork. So I need to locate right about my last hammer blow will be the position I'm going to make the bend. Likewise, that's where my fire needs to be heating the material. So I have the heat, the color you can see in the area where I need it. I'm going to lay it in between the fork here and sort of pull it with my left hand and tighten it against that fork, and then hit with my hammer blow to cause it to bend around the shape of that pin on the fork. So I've accomplished a bend without having any difficulties in making that shape. So now I have a handle that I can hold on to as soon as I cool it off, and I will do that by putting my piece of metal into the water, which this is a barrel. You might recognize it, some people, an old beer barrel that I've cut the top off of, and blacksmiths would call that a quench tank or quench tub, or a slack tub. Then, so I now have my piece ready to then transform it into the next step. I'm going to put a sharp point on the end, My piece is a little bit shorter than what I normally use in the class, so we'll end up with a shorter finished stake turner. Some people like them shorter anyway, so this is going to be shorter than the class project. Actually, in the class, I have our students practice making the sharp point. And so I'm going to show you the fundamentals of making a round, sharp point on the end of a round bar. So this starts off, you got to first understand that I'm working with a flat hammer and a flat surface. So to make something round, I have to first shape things flat, and then I will make them, from there I'll make them round. So how do I do that? I start with assuming that this heavy piece that you can see better, more clearly, assuming that this is the end of my stake turner bar. You know, obviously it's bigger, but I use it for demonstrations to visualize it better. So this is the shape of the bar, and we're going to then shape it into a square tapered point. So the square tapered point then will allow us to have the length and the shape necessary for the round point. But we need to then, after making it square, we need to convert it into a octagon shape. So I'll hammer on the square corners to make it octagon, and then after it's octagon, that octagon is, for all intents and purposes, pretty round, and if I just knock down some of the sharp edges on there, it will be a finished round point, especially when I'm working with such a small piece like this 5/16 diameter. So our step is we're going from round to square to octagon and then finishing in round. In the process of making tapers, that is the standard process for in all applications of whatever we're doing in blacksmithing. We start with round, we go to square, we go to octagon, and then we go back to round. So I'm going to start off with my hot material. I'm going to come over, since that cone or that pyramid is at slightly tapered, I need to hold my metal against the anvil at a slight angle, and my hammer likewise at a slight angle. And so I'm going to then hammer about an inch to that end until I get flat on two sides. My hammer's hitting one side, my anvil's actually hitting back on the bottom side. Then I'm going to turn it 90 degrees, quarter of a turn, and repeat that process. So now I have 4 flat surfaces on my piece, 2 of them created by the anvil and 2 of them created by the hammer, and at 90 degrees in increments. So I'm going to go back into the fire, reheat it so I got some more soft metal to work with, and then come back and repeat the process. I'm coming out of the fire with my metal back up to my forging temperature. I'm going to repeat by hammering, turn it 90 degrees, make sure my hammer is also tipped at a slight angle, the same as my metal is tipped at a slight angle to the anvil. And I'm going to continue to hammer until I pinch off the tip of this piece of metal against the outside corner of my anvil to make it a very sharp point on the end. So I want this to be able to easily hook into the steak that we're going to be working with on the barbecue. Not me, you guys. Take this home and use it on your barbecue. So I've created a quite sharp end. I need to make my tapered a little bit longer so I can accommodate the length of the material that I need to make that entire hook. So I'll need maybe another inch of material that's tapered out to make that shape. So I'm going to go back in the fire and repeat that process. So I'm looking at my metal temperature, taking it out of the fire, taking a look at the color of the metal, going back into the fire. I want to make sure now that I have a very sharp, small area on that point of that I don't overheat the metal and cause it to burn. So I'm coming out at a high temperature, but not a burning temperature. pan, and then hammer it again. Let the hammer hit the top surface, and the anvil hit the bottom surface. I'm about finished with it, so I'm going to take a look to see if there's any spots around the edges that need to be cleaned up and shaped, but I'm pretty much done. I have to be very careful about hitting the end of my metal when it's down to the black temperature like that. The metal doesn't like to be forged in the 1,000-degree range all the way down to about 600 degrees. It's in a brittle zone, and it doesn't like to be moved around, and what it will do is it will split. So I got to be careful about that. I almost split the end of this. I can see a very tiny little crack on the end. It's just one of the nuances of the steel we're working with, and you just have to accommodate the steel characteristic and not abuse it in a way that will cause it to crack or break. So I got it back up to a good working temperature. Now I'm going to look at the sharp corners and hammer those corners down into my octagon shape. So I'm going to hammer all 4 corners to make an octagon. So my metal now is tapered the length I need, and it's octagon shape. So my next step then is to smooth out any of those sharp edges on the octagon. I'll go back in the fire, get it up to just a red temperature, so it's soft enough to hammer without cracking or being destroyed by overworking it. So I'm going to use my hammer as a tapping device, and I assume my hammer is going to find any of the surfaces that are standing up that are taller than the low surfaces, and that will make the point smoother for the entire taper. So this is just a random process of hitting until I think everything is smoothed out. Hitting very hard, you can tell it's very light blows. So I'm just doing what I would call planishing the surface, smoothing it out. And I have some small hammer marks left in there, but for the purpose of our project, it's not going to affect the function of that meat turning hook on the end. Alright, so what's our next step? Our next step is we need to make this hook on the end. So we're going to go back then to our animal horn, and look at the size of that hook, look at the diameter of the horn, pick a spot that we think is going to be the right size for the shape of the hook we want, and bend it around that horn. So back up to a convenience temperature here that I can bend it, and find the diameter that I need, and tap it, move the metal underneath my hammer, and just continue to let it take the shape of the horn. So you can see the curve is starting to develop there, and come on around a little bit more. I need that curve to be like the half of a turn. So I'm going to take a look at that and say I think I can bend it back by putting the piece on top of my horn and bend it. If I need a little more bend, I can add a little more to it. And I can come back and finish the shape of that by bending against my horn. And so I have then a hook that will allow me to penetrate the steak and work fine, I think. So, but the hook is in the wrong direction. It needs to be bent 90 degrees. So offset like this. So I need to bend that hook to the side. I will do that again by going in the fire, and I'm going to use my anvil for bending. I probably could use my fork, but this is going to give me a more my sharper corner bend. I'm going to place my piece over the edge of the anvil. For convenience of photographing this, I'm going to work on the opposite side that I normally work on. So I'm going to come over here and lay the hook over the edge and then bend it down against the side of the anvil.
Ready?
Ready? Okay, so now we have our hook finished, and now we're going to make the decoration in the middle. We're going to do this by first flattening out on the steel the length of what the decoration is going to be. I'm going to flatten this in about half the thickness of my original metal stock. And then after I do that, I can then show you it's going to be twisted. We'll do that in the vise. So first step here, I've got my metal in the forge, and I'm holding it with a pair of tongs that fit the size of the shaft, and holds it tightly so I can put it in and out of the forge without having any danger of it getting dropped on the floor or lost or whatever. Anyway, so my tongs have to have the correct size jaw in order to fit the metal that I'm working with. All right, we're coming out of the fire at a high temperature, and I'm going to flatten that metal for the length that I want to have the decoration. So I have turned the round into a oval shaped flat. I'll straighten it out a little bit, then go back into the fire. So my next step, I'm going back into the fire to reheat the metal in the same location that I just got through heating and hammering. I will come out of the fire, assuming this is the piece I'm working on. I'll come out of the fire and I will clamp the metal in my vise tightly, and then I will take another piece of round, convenience round steel, and slide that through the handle, and I'll use that as a twisting bar to twist the metal around, and the vise holds the other end. I'm coming out of the fire. I need to make sure my handle that I'm going to be using for twisting is cold. I'll put that into my water, cool it off. That will make sure it's strong and not going to bend itself while I'm doing the twisting. So I've got it now in my vise. Put my bar through here. I'm going to turn this handle about 2 to 3 times. That's one full turn. I'm going to do another full turn. I'm going to look at my twist. If I think I need a little more to decorate it, I'll do another full turn. And I align my handle with the tip of the sharp point on the hook. So that I now have it shaped the way I want it. I've got the decoration in there. Grab hold of my tongs. And I've got a little bit of bending going on because I probably wasn't very careful about doing the twist. And I'm going to put it in the vise and use that to help straighten my metal and make it more appealing when I get through here. So I've straightened it out. No, I haven't. My eye says it's almost straight, but it's not. And I could even come over to the anvil and maybe tap it a little bit. I have some little bends or kinks or something I don't like. Just a couple little convenience taps will help straighten that out. Then the next step I need is to protect that with the wax. What I have on here from the fire, some of the scale and smoke and soot from the fire. I'm just going to take this wire brush and remove anything that I can from that surface. The metal is quite hot. It needs to be about 500 degrees in order to melt my beeswax and to cover the entire surface with the beeswax. I did cool off the handle in the water, so I'm thinking that my handle needs to be a little bit warmer than what it was just after being quenched in the water. I'll warm it up a little bit, let it soak some. I do not want my temperature of the metal to be above about 700 degrees because then it will burn and flare up, and I'd rather not. So I have a chunk of wax. It's beeswax. Fortunately, my son is a beekeeper, so we have access to wax. And I'm going to melt that onto the surface. There's my handle, which I'll warm back up, is hot enough to melt. That's good. If it wasn't, I'd have to go back in and reheat it. But I just want the wax to flow over the surface in all areas. I got to be real careful to wear my gloves while I'm doing this because the wax, the metal is, like I say, at least 500 degrees. And I can have accidents happen of getting burned in this process, and I don't want that to be the case. So I have it wetted with the wax. I will take a convenience rag that I've used for this process many times, and I'm going to wipe off the surface to remove any of the liquid wax on the surface, so that it's only the wax that has actually gone in and sort of penetrated the outside scale and surface of the steel is left on there. That way, when you use it out in the sunny day on your back porch, you don't have a sticky surface. It's just the dry wax is on the surface. So it gives me a finished look. I now have my finished piece. It's still a little bit warm. You can see the smoke coming off here, so I think I will not hold it with my glove and just show it to you. The wax gives it a nice dark black finish, and it's perfect for going to your barbecue to be used. So that concludes the demonstration for the use of our beginning project on beginning blacksmithing, and so I hope you all enjoyed that.